This is Dr. A. Anuja, Assistant Professor, Department of Mathematics, Arulmigu Palani Andavar, Arts College for Women, Palani. In this lecture, we are going to see about statics and their basic concepts. Now, statics is one of the branch of mechanics, and mechanics has two concepts. Those are statics and dynamics. In this lecture, we are going to see about the statics and their basic concepts with the suitable example. What is statics? Statics is a branch of mechanics which is concerned with the conditions under which body remains at the rest when acting on by forces, which is called the statics. These are the basic concepts of statics. We have to know what are the basic topics for the for our topic. Now we are seeing the body, so which is the portion of matter, it's called the body. The next one, rigid body. A body consists of innumerable particles in which the distance between any two particles remain the same in all positions of the body, which is called the rigid body. And the next one, particle. A particle is a body which is very small and whose portions at any time coincide with the point. The next one, motion. If a body changes its positions under the action of forces, then it's called the motion. And the next one, path of particle. Every particle has a path. In this concept, the curve joining the different positions of the particle in a space while in a motion, that is called the path of particle. And the next one, speed. The rate of at which the body describes its path, it's called the speed, and speed is a scalar quantity. And the next one, displacement. It is a change in the positions of a particle in a certain interval, which is called a displacement, and the displacement is a vector quantity. And the next one, velocity. The rate of change of displacement, it's called the velocity, which is also vector quantity. And the next one, acceleration. The rate of change of velocity, it's called a acceleration. This is also vector quantity. And the next one, equilibrium. A body at rest under the action of any number of forces on it, it's said to be in a equilibrium. Here we are seeing the one example for the equilibrium. In this concept, we'll take two forces, that is P and Q. So these two forces acting on a body, and they have an equal magnitude and the opposite directions on the same line of actions, then it's called an equilibrium. And next one, force, that is a vector quantity, and force is any cause which produce or tends to produce a change in the existing state of rest of a body, or it is a uniform motion in a straight line, which is called a force, and the force is represented by a straight line. It has a both magnitude and the directions, and the different type of forces are we are seeing. So those are weight, attraction, repulsion, tension, thrust, friction, and etc. And the Newton's third law is action and the reactions are always equal and opposite. Next we are seeing the force acting at a point concept. The forces are represented by a straight line which magnitude and the directions. Here the force acting on a rigid body may be represented by a straight line, so they have a magnitude and directions which are passing through the same point. So we say the forces are acting at a point. In this example, we'll consider the bulk of forces. Those are P1, P2, P3. So these are the forces. These forces are acting on a rigid body. So it is easy to find a single force whose effect is same at the combined effect of P1, P2, P3. So which means we are applying the number of forces on the rigid body. It will give a one single force, which is called the resultant force. So here P1, P2, P3 are called the component of the resultant. So for this concept, we are seeing the one theorem. So that is fundamental theorem in statics, which name is a parallelogram law of forces. If two forces acting at a point to be represented in magnitude and directions by the sides of the parallelogram drawn from the point, their resultant represent both magnitude and directions by the diagonal of the parallelogram, so which is given in the figure. So here we are considering A, B, C, D is a parallelogram. So how we construct this parallelogram? We are saying this. AB is a line for the parallelogram. Here P is a force. The force is along the side AB, and the next Q is a force which is acting along AD. These two forces acting at a single point A, which will produce a one single force, that is R. This force is act along AC. That R is called the resultant. The expression is AB vector plus AD vector is equal to AC vector. So therefore P plus Q is equal to R. These are the forces to the corresponding sides. Next we'll join C to D and C to B. We'll get a one complete parallelogram. So the name is ABCD. And the next, the resultant of two forces acting at a point. Here we'll consider the parallelogram ABCD, and the force P is acting along AB and the force Q is acting along AD. And these two forces acting at a single point A, which will produce a one single force, that is R along AC. So here let the two forces P and Q acting at A be represented by AB and AD. So we are assuming the angle between them is alpha. So therefore angle of BAD is equal to alpha. We'll get one complete parallelogram, that is ABCD. And the diagonal AC will represent the resultant. So that is R. The resultant is R. Now we are assuming the angle A is equal to pi. And then we'll draw CE is perpendicular to AB. So now in the parallelogram opposite sides are equal. So we'll say BC is equal to AD and Q is the force for AD, and obviously the Q is force for BC because the parallelogram has a opposite sides are equal. Now from the right angle triangle CBE will find the sine alpha and cos alpha. First we find the sine alpha, and sine theta is an opposite side divided by hypotenuse. And அதே மாதிரி cos theta is equal to adjacent side divided by hypotenuse. For this we are getting sin alpha is equal to CE divided by Q, and the cos alpha is getting BE divided by Q. So we are equating these two equations. We'll get CE is equal to Q sin alpha and BE is equal to Q cos alpha. So mark it as CE is an equation 1 and mark it as PE is equation number 2. Now we'll find the resultant, that is R squared is equal to AC squared. We are substituting AC squared as an AE squared plus EE squared. So we'll expand as AE as an AB plus BE the whole square plus CE squared. Now we are substituting the formula for the A plus B the whole square. We'll get A squared plus B squared. So for this we are applying these values. We'll get R squared is equal to P squared plus 2PQ cos alpha plus Q squared. So finally we get the resultant is equal to square root of P squared plus 2PQ cos alpha plus Q squared. Then we'll find the angle. It's nothing but tan pi is equal to CE divided by AE. So we are substituting the values for the CE and EE. We'll get Q sin alpha divided by P plus Q cos alpha. Now we are seeing the three results for this proof. The result 1 is the forces P and Q are at a right angle to each other. So that means alpha is 90. So we'll get resultant is equal to root of P squared plus Q squared, and then tan pi is equal to Q by P. The case 2, resultant 2, if two forces that is P and Q are equal, so we'll get the resultant is equal to 2P cos alpha by 2, and tan pi is equal to tan alpha by 2. So we are cancelling the tan on both sides. So we'll get pi is equal to alpha by 2. And the third result, if our resultant R is greatest when alpha is greatest, so we'll get the highest value for the cos theta. One is that is cos alpha is equal to 1 or alpha is equal to 0 degree. So the greatest value of R is equal to P plus Q. Now R is least when cos alpha is least. So therefore we are getting least value of R is P minus Q. Thank you.